A rational function is a function, let's make it f of x, that can be written as a polynomial divided by another polynomial. So some examples of rational functions are x plus 1 over x squared minus 1, or even 1 over x, x cubed plus x squared over x. So any combination that has a fraction bar, and it can have x's on top and x's on bottom. Now the parent function for a simple rational equation is what we call a hyperbola. Hyperbola, hyperbola, which consists of two symmetrical parts called branches. The domain and range are all real numbers. That are not 0, because up here, and we're only talking about this one up here, you can't divide by a 0. Remember that from your younger days? If you have 0 on the outside, how many times will 0 go into 1? Well, if you say 1, you still get a 0 out here, so you end up dividing forever. So you can't have 0 on the bottom, but every other number is okay. So the asymptotes of this are x equals 0 and y equals 0. Remember, an asymptote is a line that the graph doesn't ever cross. It comes real close to it, but doesn't cross. It curves into it. So any function of the form g of x equals a over x has the same asymptotes, domain and range as a function f of x equals 1 over x. What this means is you don't have to have a 1 up here. If you have another number up there, say 9 over x, it'll still have 0 as asymptotes on the x and the y, and all real numbers for the domain and the range except for 0. But the graph will just be a little bit stretched out. So here's some examples. Graph the function y equals 4 over x. Okay, first we need to draw the asymptotes. So the asymptotes for this is x equals 0 and y equals 0. So these points we can't cross for the graphs. Now, we need to plot points to the left and to the right of the vertical asymptotes, such as, if we put -2 in for x, we'll have 4 divided by -2 equals -2. So here is that point. If I put -1 in for x, we'll get a -4 out. -1, -4. If I put a +1, I'll get a +4 out. And if I put a 2 in there, I'll get a +2. Okay. Don't just connect these together with some sort of weird curve. Remember, these are asymptotes. So what you need to do is pull it up to be asymptotic down to the 0, and then to the 0 here. Then we need to make a nice smooth curve that doesn't cross the line. Here. Okay, so do you see that this is in two parts? They're a mirror image of each other. That shape is called a hyperbola. If I draw that shape without the XY graph plane on it, it would look something like that. Mirror image parabolas. Okay. I'll let you go ahead and do this checkpoint number 1. Go ahead and draw in your asymptotes. Remember, it's just x equals 0, y equals 0. And then pick some series of points, and you'll get a curve up here somewhere, up around here. You'll get a curve over here somewhere. So go ahead and pick the points and pin the curve better than I just did. Okay, now how about translations? So here's the form for the translations. Notice the sign, negative for the h, positive for the k. And what this translation does is moves the asymptotes over. So draw the asymptotes, x equals h, y equals k. And then plot points to the left and to the right of the vertical asymptote. And then draw the two branches of the hyperbola so that they pass through the plotted points and approach the asymptotes. Let's try one of these. Graph this, state the domain in the range. Okay, notice that we have a negative sign up here in front of the 6. That's a flip just like usual. So it's going to be in the second quadrant, in the fourth quadrant this time, instead of the first and third. So we want to draw the asymptotes. X equals, where's our h? Ooh, well, we have a problem because the h is not negative the way we need it. So we need to change that positive 3 to negative 3. And then a negative 3. We can pull it straight off as a negative 3 here. Okay, and then the y is positive 2. So x equals negative 3. Notice that this graph uses 2 as a scale, so I'm going to squish this in the middle to get a negative 3 over here. And then I need y equals 2. Go up 2 on your y. Here it is. And then I want to plot some points. So if I put in negative 6 for my x, I'll have negative 6 over negative 3. No, negative 6 over negative. Oh, plus 2. So that should give me a 4. Okay, if I put a negative 4 in there, I should get an 8 out. If I put in negative 2, I should get a negative 4. If I put in 0, I should get another 0. So let's plot these points. Negative 6, again, came by 2. So 2, 4, negative 6, and then up 4, 2, 4. Here's the point. Somewhere in here. It's hard to do since it's so small. And then negative 4 and 8 would be up here. And negative 2, negative 4 is right there. And then 0, 0. So it should look something like that, except a much smoother graph on your part. Okay. The domain is all real numbers, except for, what does the x not go through? So where's my asymptotes on my x? It's the -3. And the range is all reals. Then what does my number on the y line approach but doesn't go through? And that would be +2. Okay, graph a rational function in the form y equals ax plus b over cx plus d. Okay, now to find the asymptotes on these forms, you need to take the bottom, the denominator of the fraction, there you go, this, and solve it, set it equal to 0, and then solve it, and that number will be the asymptote for the x line, x equals whatever. To find the vertical asymptote, you're going to take these numbers, the a and the c, and you're going to solve that fraction for your vertical asymptote. So let's look over here. What would be x minus 1 equals 0? So x equals +1. And that is going to be my asymptote for the x line. Now, my horizontal asymptote is a line y equals a over c. And so that's a fraction 4 over, well, we don't have an a there, so we need to assume it's 1. So that equals 4. So if I count up to 4 on my y, 1, 2, 3, 4, and I draw a horizontal line, there are my asymptotes. Now, again, I'm just going to pick points and fill in my numbers. It's a little bit harder now because I have x's on the top or the bottom. But we can do that. And if I put in -1, I will have 4 times the -1 minus 2 over -1 minus 1. So that would be -4 minus 2 is -6. -6 over -1 minus 1, that would be -2. And -6 divided by -2 is +3. And you would just keep going and pulling in several points. 6 and 5. Making sure that you pick points on both sides of the vertical line. Now we need to plot those points. So it would be -1 and then 3, 2, 3. That would be right here. And then 0, 2. Oop, I messed that up, didn't I? I need -1, 3 is right here. Okay, I'm going to X that out, and it doesn't X out very well. So 0, 2, right here. So my asymptote here is going to go like that. And then 2, 6, 1, 2, 3, 4, 5. Let's see, 1, 2, 1, 2, 3, 4, 5, 6. And then 3, 5. 1, 2, 3, 5. So here goes this one. And that's how you graph these. Or the domain. What is the domain for this? The domain is all reals again. Except, what does the x not go through? 1. The range is all reals except 4. So not 4. Checkpoint. Graph the function, state the domain in the range. Okay, how do we get our asymptotes from here? All right, x minus 2 equals 0. So x would be positive 2. Here it is. And then 3 over 1 for the vertical or the horizontal asymptote. So, okay, here's another example of teachers making mistakes. So this is not our form for the other asymptote. This is our H and K one. So here's a 1 for a K. This is a negative. It's supposed to be a negative, so I need to pull off the 2. Here's where I got the 2 line from. And then my K is a positive 1. So here would be the other asymptote. Alright, it is positive number up here for the 3. 3 is positive. So it's going to be in this quadrant, number 1 and number 3. And then just pick points and find where it goes. Okay, on 3. This time I can use that formula. So negative x minus 2 equals 0. Add 2 to both sides. So negative x equals positive 2. So x equals negative 2. So I can go over here to negative 2. And this is another weird graph that they put a 2 scale on. And then I need to get my horizontal asymptote. And I can get that from the A over C. So negative 2 divided by negative 1 is positive 2. So here would be my asymptote here. And then we have a negative sign. So that is going to flip it. It's going to be in this quadrant and this quadrant. So go ahead and pick points and graph that. That's it.